Hi everybody. So I just wanted to do a video today because I feel like I had a bunch of stuff to say and I didn't want to type it out. Okay, so item number 1 on my list is emailing me. Email me as much as you want and I will definitely get back to you. And if I don't, email me again because I get a lot of emails in a day. But here's what you shouldn't email me. Missing parts of assignments. It's so hard because there's like, I don't know, 50 people in the class. And if, everyone was missing something in an assignment and they emailed it, I would definitely miss things. And I have. Like some people have emailed me, hey, I forgot to put this in a quiz, and they'll email it. It's just like really hard to keep track of, even if, I write it down, and it's way too hard. So what you need to do, because it will take you way less time than me, since you're just doing it for yourself, I'm doing it for 50 people, you just need to just stick it back in your Dropbox. If it's a quiz problem, okay, yeah, you can't get back into your quiz, then obviously email me about that. But Dropbox problems, go to your Dropbox folder and resubmit it or add to your submission. You can do that. Just go back into the folder and, add something to it. And then you feel free to email me and say, hey, miss, I forgot to add this to my Dropbox folder, so I did it now. Cool. But if everything's in your Dropbox folder, that's the way to go. Otherwise, I'm sorry, but I can't be responsible for, oh, you missed, you didn't mark this thing that I emailed you. Yeah, that's probably true because it's so hard to keep track of. And it's so time consuming and I'm already way behind on my marking of everything, and just trying to keep track of everyone's stuff is stressing me out here. So please, 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 please put things in the appropriate Dropbox. And if you forgot something and I emailed you, hey, your file's not working, or hey, you missed this file, which has probably happened to about 15 people in the last assignment, please go back into the Dropbox and put it in there. I'll find it. Or you can email me and say, hey, I put it in the Dropbox. Sorry, I just spent 2 minutes telling you that because it's so important. So make sure all of your stuff is in the appropriate Dropbox. And take 2 seconds and double check. So data collection assignment, that's where your data collection goes, your surveys. Making conclusions, just check to make sure things are in the correct one. And you can even do a quick check, open the file that you uploaded and say, hey, it's not working, or yes, it is. So just, help me out here and try to do that. It'll save a lot of time, and then it'll make sure your mark is accurate too. And then, of course, email me anytime if I've messed up something. Okay, so that's item number 1. Get things in the right Dropbox and put them in the Dropbox. Don't email them to me. Email is good for asking questions, not for handing in assignments. Okay, item number 2. I want to talk about some feedback from all the work we've been doing. So in Unit 2, Linear Relations, you should have your data collection assignment done by now. And I was on top of marking them, but now I think 2 more people have handed it in, so I gotta mark those people's. So your data collection assignment, there's been a wide range of assignments. And when I looked back to what was required, most people actually did meet the requirements, but some people went above and beyond. So just to show you possibilities, I'm going to show you someone's work. I hope they don't mind. I don't think it has their name. Okay, this person's assignment, just to give you an idea of what you could put on your making connection or your data collection assignment. So you created a survey. So in the Dropbox, you're supposed to give me a link to your survey so that I could check out your survey. And you're supposed to give a couple of sentences or a paragraph about, how did your survey go? Were your questions good? Were they biased? Would you have changed anything? And you could summarize some information that you found from your data that you collected. Putting your survey in the discussion panel didn't guarantee that people would take it because, there's a lot of them. So you could have also maybe asked your friends to take it, or your parents or your grandparents or anyone you know. It was just, try to get someone to take it. Okay, but if you couldn't, then, just do it with no data. Okay, so somebody decided to do one on phones in the classroom, which was kind of a cool topic since they're banning phones. So the first thing they did was they summarized it. So they, you know what, Google Forms does this for you, creates all these graphs. So they went through and kind of summarized. I found that they believe their device distracts them less than it helps them. I also liked the way this person phrased it because she wrote, I found that they believe. True. That's not the truth, but that's what the people in the survey believed. So that's kind of a cool wording thing for that person. Yeah, so she just summarized a bunch of stuff. And then for her conclusion, she kind of concluded stuff from the data collection of what, what those 10 people or however many people that took her survey found. So like, that's good. And then she talked about bias. So this person used a random number generator to select people from her class to get rid of selection bias or sampling bias, which is crazy, man. That's awesome. So this person went above and beyond trying to get the data. I just thought that was really cool. And she wasn't the only one. There was like a couple people that did that, which I've never had that in the past. So that's really awesome. And then she talked about non-response bias because some people said they were too busy to do the survey. That's kind of cool. Everyone in the class had sampling bias, right? Because we're not a government agency. Like, it's hard for us to make a random survey, like a random sampling process. Yeah, so then there's a bunch of stuff. So she came up with a way to fix this issue. And then she talked about misinterpreted questions that she thought. Yeah, so she goes through that and then provides a link to her survey. I just thought this was, like a really awesome conclusion. Whoops, I just showed her name. Okay, I'm so sorry. Okay, moving on. So that's the data collection assignment. You don't have to go to this extent to get a level 4. Basically, you just need to do a survey and your questions, should be kind of like what we talked about, without bias and relevant, and, have a topic. Don't just ask 10 random questions. Okay, so that's data collection. If you go back to the Dropbox, the next thing you handed in was the making conclusions assignment. And I'm just marking this, but it's basically well done. The only problems I'm having are I can't see some people's graphs that they sent in, so it makes it so hard to mark. But for the making conclusions assignment, you just had to graph 3 things, 2 by hand. And most people's graphs are pretty good. Just a comment about the making conclusions assignment would be knowing which variable is dependent and which one's independent. So for the graphs, just knowing which one goes on the bottom, which one goes on the side. Making conclusions. Here we go. And then not forgetting to add a line of best fit. That was a major thing. And then finally, this part. A lot of people are having trouble with interpolation and extrapolation. Basically, it's just extrapolation is when it's kind of outside of the range of your data. So if you look at this jelly bean one, so we looked at how much time it takes to eat how many jelly beans you can eat in 2 minutes, and it goes all the way up to 10 is the biggest number. So as long as your data is asking you questions, or as long as the table is asking you questions between 2 and 10 minutes, that's interpolation. But if I said, how many jelly beans were left after 1,000 minutes? Okay, well, that's extrapolation because our data only goes to 10 minutes. So as soon as we're outside of that range, it's extrapolation. Or if it's before the range. So like, how many jelly beans were there at the start of this? I don't know. We're guessing. So that's extrapolation. So in this column, you just had to say interpolation or extrapolation. And then you had to estimate it from your graph. So you look at your graph and you're like, oh, that looks like 10. And that's all you had to do for that one. Okay, next. So we're in rates of change and initial value. So one of the first assignments that you hit is rate of change practice questions. This is kind of the first one was okay. So you just fill in a table of values by subbing in numbers for H and find the first differences, which can help you determine if something is linear. Then question 2 is a little trickier. So I gave you 3 tables of values And you're just looking and seeing like, ooh, are the y values going up by the same amount each time? Are the x values? And you're kind of using those to help you figure out if they're linear or nonlinear. And I don't know if you know this, but the first differences and the value that the x increases, it kind of gives us our slope, right? So y is basically like our rise in our data, and x is like our run. So we're basically getting the slope, the rise over the run, when we look at the pattern in our table of values. So B and C are kind of like bonus questions. We're going on with this in the next unit. But B says, if there's a linear relation, can you write the equation of the line? And if you can't, what further information is required? Okay, so I'll just say, out of these three situations, 2 of them are linear and 1 is not. So the one that's not linear, you do not need to write an equation for, and you don't until grade 10, because we aren't learning that in grade 9. But for situation 1 and, okay, I shouldn't say. But for the 2 linear ones, you could write an equation if you knew the slope and the y-intercept, maybe. So, this is a bit ridiculous. I just use paint. If you had a table of values and the x's went up by 1, I'm sorry about this. And the y's were like, I'll just do like an easy example since I can't even write. 0, 5, 10. You can see that the y values are all going up by 5 each time. Right? That's going up by 5, that's going up by 5. So our first differences are 5. And then if we look at what our x values are going up by, they're going up by 1. So technically it's like the rise of our data is 5 and the run is 1. So this is the slope of our graph, the slope of this relationship, whatever it is. It's going up by 5 y's per x's. So we can get that information. And then to write the equation of a line, I mean, I don't know if you know this, but you need to know the slope and the y-intercept. And we don't know the y-intercept because the y-intercept is when x equals 0. And we don't have that data. But if we did, we could kind of backtrack it. So we know it's going up by 5. So if we wanted to backtrack it one value where x was 0, then it seems like y would have to be -5 to follow this pattern. So now I know that if my y-intercept is -5 and my slope is 5, I can make an equation like y equals mx plus b. So 5x minus 5. This we're going to get into more and more as the unit goes on and in unit 3, but this is basically how you write the equation of a straight line. Y equals the slope times x plus the y-intercept. And you'd need to be able to find those from your table of values. And you're not required to do that when it's not a straight line, because that's grade 10 stuff. But if anyone's interested in exploring that, we could do a virtual classroom on that one day and we could talk about that. Or I could make a video. Okay. So that's that practice thing. And then one more comment, the quizzes. So if you're doing the representing linear relations quiz, this is what the quiz looks like. It's 7 questions and most of them are multiple choice. And you're just seeing which ones are linear and you're doing a table of values and blah, blah, blah. There's a weird question though. I'm sorry about this. Question 4. In this equation, c equals 8n plus 25. You have to answer the question, how many pledges are needed to raise $850? Okay, so none of these are exactly the answer. So I guess you have to pick the most correct answer. So you need to raise at least $850. So there's one that's close. There's one that doesn't quite get you there, and then there's one that gets you more than there. So that's the one you got to go with. So just so you know, question 4 is a little bit odd, but there is a kind of correct answer. I don't know what happened. Maybe I messed up that. But anyways, so yeah, it's a bit weird, but you want to pick the one that gets you to 850 or the closest you can without, like, you don't want it under 850 though. Okay, cool. Yeah, that's it. I think that's all I wanted to say. Hopefully the course is going well. I'm sorry I'm not meeting my 9 a.m. timelines very often. But today, if you're on track, you should be getting into the direct variation content and practice assignment. And definitely, guys, by the end of this week, this is my goal, again, another goal. I need to be caught up on marking your data collection, making conclusions, and your quiz. So I got to get those guys marked for you. And you're investigating linear relations. So you can check back here, the Dropbox, for your feedback, and check the quizzes to see how you did there too. Okay, but basically, if you took anything away from this video, it is make sure all your stuff is in the appropriate Dropbox and not emailed to me. Okay, thank you. Bye.